Foster Wheeler is advancing steam generation technology with its state-of-the-art circulating fluidized bed technology. Unlike other steam generator technologies, a CFB doesn't have burners or a flame within its furnace. Its unique low-temperature fluidized bed combustion process can cleanly and efficiently burn a wide spectrum of both traditional and carbon-neutral fuels, such as biomass, waste coals, tires, and processed waste materials. Conventional pulverized coal combustion technology requires the fuel to be finely ground and dried before entering the furnace. Due to the forgiving nature of the CFB combustion process, these steps are not needed. Instead, the fuel is coarsely crushed and dropped into fuel chutes, which lead to ports in the lower section of the CFB furnace. As the fuel particles enter the CFB furnace, they are lifted or fluidized by primary combustion air, flowing through hundreds of specially designed nozzles in the floor of the furnace. Additional secondary combustion air is fed through ports located higher up in the furnace. The way this air is introduced into the CFB results in vigorous mixing of the solid fuel, limestone, and ash particles, allowing the CFB to cleanly burn almost any combustible material. The particles eventually reach the top of the furnace and then pass through compact solid separators that capture and return most of them back to the furnace. The compact separators are an advanced design feature of Foster Wheeler's CFB technology, which are made up of steam-cooled panels that are fully integrated with the furnace to form a single monolithic structure. Once separated from the hot furnace gas, the captured particles flow from the bottom of the solid separators and then into loop seals. The loop seals maintain the pressure balance between the furnace and the exit of the separators, allowing the solids to flow back into the furnace, even though the solids are traveling into a higher pressure zone. Foster Wheeler's loop seal design is proven in the industry for being highly reliable. Another advanced design feature of Foster Wheeler CFBs is a high-performance particle-to-steam heat exchanger called an Intrex. The Intrex efficiently extracts high-temperature heat from the hot particles in the CFB to produce high-temperature superheat steam. Foster Wheeler CFBs are designed to operate at low uniform combustion temperatures, optimizing the capture of pollutants, such as oxides of sulfur and nitrogen, as the fuel burns. This temperature is well below the melting point of the fuel's ash, allowing the CFB to burn fuels considered too corrosive for other steam generator technologies. With today's heightened concern for carbon emissions, Foster Wheeler CFBs have successfully burned biomass, recycled and waste materials, providing a reduced carbon solution for large-scale utility power generation, as well as for industrial and district heating plants. To lower emissions another notch, Foster Wheeler has coupled fuel-flexible CFB combustion with highly efficient vertical tube supercritical steam technology. Supercritical steam technology allows more of the fuel's energy to be converted into electricity, conserving fuel while producing fewer emissions. For the long term, Foster Wheeler is developing FlexiBurn technology, which will allow the CFB to generate a CO2-rich flue gas and be part of a practical CO2 capture and storage solution, capable of reducing CO2 emissions by over 90%. Circulating fluidized bed technology is an important part of the solution to meet the world's energy needs, while conserving natural resources and preserving our environment. Visit Foster Wheeler at www.fwc.com for more information on this exciting technology.